When watching a beautiful sunset over the sea and in the mountains, have you ever thought about what a sunset on Mars looks like? Or on Venus? Do they have the same reddish hues as sunsets on Earth? Not really. You see, sunsets look very different on different planets because of the composition of their atmospheres. Sunlight scatters off of the molecules that make up an atmosphere. This process is more effective at shorter wavelengths, which is the blue end of the visible spectrum. That's why we perceive the sky on our home planet as blue. But at sunset, light needs to travel longer distances through the atmosphere. That's why we see yellow and red hues. Now, let's move to Mercury and check what sunsets look like there. Both sunrises and sunsets on Mercury are views to behold. The sun seems 2.5 times larger in the sky over this planet than when you look at it from the surface of Earth. It also rises and sets twice during a Mercurian day. It rises, arcs across the sky, stops, moves back to the rising horizon, stops again, and restarts its way toward the setting horizon. Such bizarre maneuvers occur because Mercury rotates 3 times for every 2 orbits around the sun, and its orbit is extremely elliptical. But if you expect to see a blazing sky and the hues of red, you'll be disappointed. Mercury has almost no atmosphere, so its sky is always black since light doesn't get scattered at all. Let's continue our journey and go to Venus. There, at sunset, a bright yellow fades into orange, brown, and then when the sun disappears, black. The planet rotates on its axis very slowly, so to see a sunset, you'd have to wait almost 1/16 times as long as you would on our home planet, half of a Venusian year. Mars is widely known as the red planet because of its rusty color caused by the presence of iron oxide in its soil. But sunsets on this planet would look surprisingly blue if you watched them from the surface of Mars. Fine dust in the atmosphere of the planet scatters light and makes the blue hues around the sun's area of the sky brighter. A Uranian sunset is azure, fading into royal blue with some hints of turquoise. The pretty colors come from the interaction of sunlight with the planet's atmosphere, which mainly consists of hydrogen, helium, and methane. These gases absorb the longer wavelength red portion of the light, and the shorter wavelength blue and green light gets scattered when photons bounce off the gas molecules and other particles in the atmosphere. In 2014, scientists working with data received by NASA's Cassini mission showed what a sunset on Titan could look like. The largest moon of Saturn is surrounded by haze and smog. It's the only satellite in the solar system with a measurable atmosphere, which mostly consists of nitrogen, around 95%, and methane, about 5%. High in the atmosphere of this moon, the nitrogen and methane get split apart by the ultraviolet light from the sun and high-energy particles accelerated by Saturn's magnetic field. The compounds produced during this process create a thick, orange-colored smog. As the sun sinks toward the horizon, these orange hues turn into a deep brown. Now look at this. It looks like a sunset on Earth, right? But it might actually be what it looks like on Saturn. We have to say might because, just like all images from space, we can rarely get the color right. They are neither true nor false. They just represent the physical processes underlying the subjects of the images. As for the photo of a sunset on Saturn, it's hard to say if it looks exactly like this before we get more scientific data. We finally know when Earth will cease to exist. It'll happen when the sun enters its red giant phase. Are we going to survive long enough to witness it all? Let's figure it out. In 5.4 billion years from now, our star, which is a yellow dwarf at the moment, will run out of hydrogen in its core. The sun's core will heat up and become denser, causing the star to grow in size and turn into a red giant. The expanding sun will get so huge that it'll encompass the orbits of Mercury, Venus, and probably Earth. Even if our planet survived being consumed on the spot, it'd still end up so close to the heat of the newly born red giant that it'd scorch our planet. No life would be able to survive there. At the same time, there might be another outcome. As the sun expands, Earth's orbit might change too. You see, when our star reaches the final stages of its stellar transformation, it will lose unimaginable amounts of mass through extremely powerful stellar winds. It'll keep growing and losing mass, making the planets of the solar system spiral outward. So can it help Earth escape its dooming grasp? According to astronomers' calculations, our planet will not survive the expansion of the Sun in any case. By the time our star reaches its largest radius, which is going to be 256 times its current size, it'll be down to a mere 67% of the mass it has now, and the expansion process will be very rapid. The Sun will sweep through the inner solar system in only 5 million years. At one point, it'll enter a short helium-burning phase, which will last around 130 million years. During this time, it will expand beyond the orbit of Mercury. After that, the Sun will swallow Venus. By the time our star approaches Earth, it will be already losing as much as 8% of Earth's mass every year. Speaking of our planet's chances, we've got some kind of a good news, bad news situation on our hands. The bad news is that our planet won't be able to live through the expansion of the star. Even if Earth's orbit became 50% more distant from the Sun than it is today, it'd still have no chance. The Sun would engulf our planet even before reaching the peak of its red giant phase. After that, the star would still have 500,000 years and 0.25 AU to grow. Once Earth is inside the Sun's atmosphere, it will start colliding with particles of gas. Its orbit will begin to decay, and the planet will spiral inward. If Earth was just a bit farther from the Sun right now, at 1.15 AU, it would survive the expansion phase of our star. But what can be considered good news in such a tragic situation? Well, long before the Sun enters this red giant phase, the habitable zone around it will be gone. The heat from the Sun will evaporate Earth's oceans, and solar radiation will blast away the hydrogen from the water. Devoid of its main source of life, Earth will eventually become molten. It doesn't sound like good news, that's true. But the upside of this situation is that humanity will be bound to leave our planet long before it gets swallowed by the Sun. We just won't have a choice. Of course, we can't be sure that some other catastrophic event won't claim us before we have time to colonize some other world. An additional benefit of the changing boundaries of the Sun's habitable zone might be the restructuring of the entire solar system. Even though Earth won't be in our star's habitable zone anymore, most of the outer solar system will be. This zone will stretch well into the Kuiper Belt, which means that the formerly icy worlds will melt and liquid water will appear beyond the orbit of Pluto. So maybe that's where our new home will lie. Solar activity is approaching its peak, and it might be as dangerous as it sounds. Scientists think it's likely to begin by the end of the year 2023, and that's years before it was predicted to start. From a distance, the Sun seems to be calm and steady, but if you zoom in, you'll see that its surface is constantly seething and churning. It keeps transforming from a uniform ocean of fire to a chaos of warped plasma and back again in a repeating cycle. Every 11 years or so, the magnetic field of our star gets tangled up. Imagine a ball of tightly wound rubber bands. That's what it looks like at such moments. And then, at one point, it snaps and flips completely, turning the North Pole into the South Pole and vice versa. Right before this event, the Sun steps up its activity. It starts to spit out giant blobs of fiery plasma, emit powerful streams of radiation, and grow planet-sized spots. This period is known as solar maximum. It's a rather dangerous time for Earth since it gets regularly hit by solar storms. Such storms have the potential to disrupt communications and damage power infrastructure. Even worse, solar storms can harm astronauts working in space and even make satellites crash into the planet. At first, experts were sure that the current solar cycle would reach its peak in 2025. But judging by recent numerous sunspots, intense solar storms, and some other rare solar phenomena, solar maximum is likely to arrive as early as the end of this year. At the same time, most forecasts predict that the current cycle might peak in late 2024 and it's still 1 year earlier than NASA and NOAA had expected. During this maximum, around 185 sunspots will appear every month. But that's not too bad. Such a cycle is considered quite average compared to the historical record. The current cycle, which is the 25th since people started to record them in 1755, began in 2019 and was supposed to be really mild. You see, solar cycles vary in intensity. The weakest ones on record produced fewer than 100 spots per month during their peaks, and the strongest could produce more than 300. Why do the latest estimates differ so much from the initial ones, though? The thing is, it's still pretty difficult to forecast solar cycles. Plus, don't forget that we only have 25 cycles on record. It means the amount of data available for computer modeling is quite limited. These days, researchers explore alternative ways of predicting the behavior of the sun. They're based on the star's magnetic activity. Scientists have found out that the strength of every next solar cycle depends on the time when the magnetic field of the previous cycle vanishes completely. This event is known as the terminator. The terminator doesn't happen exactly at the solar minimum. No, it might still be up to 2 years till the next solar cycle starts to stir, waking up slowly. At the solar minimum, the magnetic field of our star is powerful and well organized. There are 2 distinct poles, like the ones a regular dipole magnet has. This magnetic field contains the sun's superheated plasma close to the surface, suppressing solar activity. But at one point, the magnetic field starts getting tangled again. Some regions become more magnetized than others. With time, the sun's magnetic field weakens. Solar activity starts to increase. Plasma rises from the surface of the star, forming giant magnetized coronal loops, peppering the sun's lower atmosphere. These horseshoe-shaped fiery ribbons then snap when the magnetic field realigns, releasing bright flashes of radiation and light. Those are solar flares. These flares often bring about huge magnetized clouds of fast-moving particles, coronal mass ejections. A few years after the solar maximum, the sun's magnetic field flips. That's the end of the solar cycle and the beginning of a new solar minimum.
Move over, Star Wars. Astronomers have discovered an exotic star system that puts you to shame. Did you know our solar system is a bit of a loner in the galaxy? Most stars actually have companions, and some even have multiple. For example, binary star systems are very common, consisting of 2 stars orbiting around a common center of mass. Usually, you can't see them with a naked eye. To an observer on Earth, they'll most likely mold together and appear to be one. For example, Alpha Centauri A and Alpha Centauri B together form a binary system. They're some of the brightest stars in their constellation and the 3rd brightest in the night sky in general, outshined only by Sirius and Canopus. But if you look at them, they'll appear to be a single star. Although it's not always like this. There are also so-called double stars. They're located so close that they may seem like a binary system, and they can either be one or not. You can even do a little eye test. In the Big Dipper constellation, try to look for Mizar and Alcor. They're kind of hard to spot, but they're right there on the arm of the Big Dipper. Now, if you're able to see them not as one, but 2, then you have good eyesight. And hey, why settle for just 2 stars when you can have more? Triple systems are also quite common, with 3 stars orbiting around each other in a delicate cosmic dance. These systems can be full of surprises because the orbits are so difficult to predict. But all this pales in comparison with the recent discovery. A few years ago, a team of researchers discovered an actual 5-star solar system. It's located 250 light-years away in the Ursa Major constellation and was discovered by the Super-WASP project. All of the stars there were formed from the same disk of dust and gas, and now they're connected in one complex gravitational dance. Now, this doesn't mean they're all incredibly close to each other. They don't do some kind of a square dance, you know. In fact, they're separated by more than the distance of Pluto's orbit around the Sun. Usually, such large systems consist of smaller ones. For example, in this case, there are 2 stars that are super far away, 2 stars that are so close that one is practically stealing the other's hydrogen, you bad boy, and one tag-along lone companion. But they all orbit around a common center of gravity. With all these interactions, it's a wonder they don't collide and create one big bright mess in the sky. But it's not surprising that each such system is more complex and rarer than the previous one. And this all raises the question, what kind of unique environments could exist in such systems? What would our life look like if we lived there? Well, let's see. Picture this. You're on a planet orbiting one of the stars in a quintuple system. It's a sunny day, and you're ready to hit the beach. As you step out of your space house, you look up at the sky and see not one, not two, but 5 suns shining bright like diamonds. 2 of them are super close together, almost as if they were one. Then you see the other pair, a bit further apart, each with their own glow. And finally, the loner star in the corner, just doing its own thing. It's overwhelming, to say the least. Now, you might be wondering, but what would the day-night cycle and changing of seasons look like on such a planet? Well, here things might get a little complicated. Depending on the orbits of the stars, the planet could experience pretty random daylight and darkness hours. They can even be constant or last for very long periods of time. All depends on the location of the planet. If we lived in a binary star system, things would be easier. There would be 2 distinct periods of day and night as the planet orbits around the 2 stars. But with 5 stars, their brightness and position would be constantly changing, so the day-night cycle could get extremely chaotic. Hey, I need my sleep here. On the other hand, this would make for some pretty spectacular views. We could experience several different sunrises and sunsets, each of different brightness and color per day. The changing of seasons doesn't get easier. You know how on Earth we have 4 seasons caused by the tilt of our planet's axis in relation to the Sun? Well, in a 5-star system, the locations of the stars could drive our planet insane. It's like having multiple chefs in the kitchen, all trying to cook different dishes at the same time. For example, if we're closer to star A, we experience more summer-like conditions. If we're closer to star B, things will be more chilly and wintry. And if we're located somewhere in the middle, we'll experience both summer and winter at the same time. It's like trying to juggle multiple balls at once. And this is a super simplified explanation. There are also things like the planet's orbital path, the tilt of its axis, the gravitational pull, yada yada. In short, the weather forecast will now become 10 times more unreliable. I'd hate to be the weather person on TV. That's a no-win scenario. And if that's not enough, then how about a roller coaster of radiation? The nasty solar winds and heat from multiple stars could make the conditions on our planet super harsh, rendering it uninhabitable. For example, if you're unlucky enough to live too close to the binary pair of stars, you'll feel like you're constantly stuck in a microwave. But hey, at least you wouldn't have to go to the tanning salon. And if you're too far away from the stars, it would be like living in an eternal winter wonderland. And if you're somewhere in the middle, well, imagine living in a place where you can get sunburn and frostbite on the same day. And this is just the beginning. You see, with 5 stars in the mix, there's a whole lot of gravity to go around. That's like being in a group hug with some really strong and clingy friends. The gravitational forces from the stars could tug and pull at the planet, creating tides so strong they could wash away entire cities. And don't even get me started on the earthquakes. With all that gravity, the ground beneath our feet would feel like it's constantly shaking, rattling, and rolling. On the bright side, though, at least we'd always have an excuse for being late to work. Sorry boss, I got caught in a gravity wave and ended up on the other side of the planet. You're not buying that, are you? As you can see, we'd have to try hard to adapt to such a system. All this, obviously, would create some challenges for agriculture. With multiple stars in the sky, plants would have to adapt to receiving light from different angles and intensities throughout the day. Farmers might need to create something to protect crops from excess heat and radiation. On the other hand, having multiple sources of energy from the stars is pretty awesome. Imagine fields of solar panels soaking up the rays from all 5 stars. But hey, maybe we would have been lucky and ended up on a planet where gravity and temperature changes wouldn't have bothered us so much. In that case, Living in such a unique and inspiring environment doesn't sound too bad. It would have a great impact on our culture, arts, technology, and so on. With such a unique view of the cosmos, people would have a whole new canvas to work with. And just imagine, this isn't even the most complex of the systems we've discovered. For example, have you heard of AR Cassiopeia? It's a septuple star system, meaning it has 7 stars orbiting around each other. Now you might be thinking, wow, that must be a real chaos. And you're not wrong. Imagine trying to navigate a spaceship through all those gravitational fields. It's like playing a game of cosmic pinball. But all this serves as a reminder of the incredible diversity of the universe. Scientists continue to study and learn more about these rare and fascinating systems. And who knows what other mind-boggling star systems are out there, waiting to be discovered. Systems of 10, 15 stars. Nearly as many stars as there are in Hollywood. Get it? Stars? Hollywood? Okay, I agree, it's lame. Consider the rogue planet, the cosmic wanderer that nobody wants to take home. Basically, a rogue planet is a planet that has been ejected from its own star system and is now floating aimlessly through space like a cosmic loner. These planets aren't just a theory. Scientists have actually detected some in our galaxy. In fact, estimates suggest that there may be lots of these cosmic nomads floating around the Milky Way. And they aren't just small rocky worlds like Earth. Some of them are actually massive gas giants, many times larger than Jupiter. These behemoths could potentially have their own moons, and even their own mini-systems orbiting around them. For example, one of the most famous rogue planets we know of has a complicated name. Here, you read it for yourself. It's located about 80 light-years away from Earth, and it was discovered in 2013. This rogue planet is estimated to be around 6 times the mass of Jupiter and is believed to be around 12 million years old. And yes, just because these cosmic loners don't have a star, it doesn't mean they're super cold. They can still generate heat and light from their own internal processes. Some may even have magnetic fields and auroras, just like Earth. In other words, rogue planets could potentially be habitable if they have the right conditions. So, what would life on such a planet look like? And could we potentially live in such a world? Well, living on a rogue planet can be a lonely existence. They have no warm sun to bask in, no cozy atmosphere to cuddle up in, and no cosmic neighbors to have barbecue with. That's why we'd have to get creative. Let's start with the most obvious problem. We'd have a hard time without light and heat. So, how do we fix this? Well, we'd probably have to invest in some really fancy space heaters and wear fashionable super-warm spacesuits. Or we could invent a whole new way to generate electricity without relying on solar power. For example, how about using geothermal energy? Now that's hot stuff. Each planet has an internal source of heat. Without it, they would all be nothing more than cold, lifeless rocks floating through space. This internal heat can be harnessed and used to power everything, from homes to factories to spaceships. It's like having a hot tub big enough to power an entire city. And that city, most likely, will be located underground, closer to the heat source. And as for light, well, we'd probably have to build some really bright flashlights. Or maybe even learn to genetically engineer some bioluminescent organisms to light up our homes. Just imagine, space is overgrown with neon mushrooms and plants. By the way, speaking of plants, plant life would be pretty hard to come by without a star. So, what would we eat? Well, we could use the same geothermal vents that we talked about, or some chemical reactions to sustain ourselves. And hey, maybe we'd develop a taste for sulfur-rich foods, or we'd start fermenting our own drinks from the bubbling volcanic mud. Yum! But besides food, we'd have a more important problem. Living on a rogue planet would be breathtaking, literally. We'd have no air. You see, not all rogue planets have good, stable atmospheres. It all depends on their size, composition, and other things. But even if our new home does have an atmosphere, it may be incredibly thin and unstable. We'd have no pretty blue skies or dramatic sunsets to admire. Instead, we'd be staring out into the infinite void of space, where the stars would be brighter than ever before. And forget about weather patterns. Without an atmosphere to create them, we'd have no rain, no snow, and no thunderstorms. And that's just some minor problems. What's worse, the temperature on the planet would be wildly fluctuating, swinging from unbearable heat to unbearable cold. It would be like living in an oven that's always being turned on and off. And finally, we'd be exposed to all kinds of space debris and cosmic radiation. So, if you don't want to get crispy, you might want to invest in some serious SPF. So, how do we fix it? Well, we'd have to find a way to generate our own oxygen and probably create something like a space-age biosphere. For example, we could grow some plants that could produce oxygen, or we'd learn to filter the air like a high-tech air purifier. Finally, we have the last most important problem, finding water. And here's where the underwater oceans come to our aid. Now we're really diving deep into the possibilities. Nyuk nyuk. But seriously, scientists suggest that some of these planets may indeed have underwater oceans. It would be like living on a giant water balloon that's been buried underground, with the ground beneath your feet made of ice and rock. In other words, we could just tap into these underground oceans. They could provide us with a source of water for drinking, farming, and manufacturing. Maybe even with some other resources and materials we've never seen before. And by the way, who knows what kind of strange creatures might be lurking in those underground seas? But don't worry. Even if we don't have any underground oasis, there are also other options. We could get some water from comets, ice mining, and even from the atmosphere, the one we just created before. Finally, we need to find and mine some resources to build our homes and other stuff. And a rogue planet might not have the same kinds of resources as a planet that orbits a star. It's like trying to find some treasures in a desert, not exactly a sure thing. We may have to rely on resources from nearby asteroids and things like that. And if we want to extract resources from the planet itself, we might need to drill down through miles of ice and rock. But hey, if you're up for the challenge, there'll always be a chance you'll strike it rich on a rogue planet. And who knows, maybe you'll discover some new resources that are even more valuable than gold or diamonds. Great! Looks like we've solved the most important problems. Now, there may be other small difficulties. For example, we'd also have to deal with some seriously long days and nights, depending on how fast our planet was rotating. And we wouldn't have a normal, regular day-night cycle. The rotation of our planet could be wildly unpredictable. Maybe we'd have weeks-long nights, followed by weeks-long days, which could really mess with our sleep schedules. We might have to develop some really strong coffee to keep us going through those long, dark nights. But, hypothetically, we can adapt to all these things and overcome all the challenges. And now, finally, welcome to the Rogue Planet, where the sun never rises, but the adventures never end. Thanks to our advanced technology, we've managed to create a comfortable and habitable environment in this once barren world. The sky above us is now a beautiful shade of blue, filled with fluffy white clouds and the occasional flock of flying creatures. Don't ask. As we venture out from our underground habitats, we're greeted by a world that's full of surprises. Strange plants and animals have adapted to the unique conditions of this planet, some with bioluminescent features that glow in the dark. And be careful if you want to go swimming in the underground ocean. They might be home to some bizarre creatures who want to feast on… well, we'll come back to that. Maybe. As you can see, we've created sprawling cities and thriving communities, powered by the planet's geothermal energy. We also created a bunch of artificial light sources that keep things bright throughout the dark, chilly nights. Of course, we still have some problems with navigation and timekeeping, but things aren't as dull as they used to be, are they? Overall, living on a rogue planet would definitely have its challenges, but it could also be a pretty exciting way to experience the universe. And who knows? Maybe someday we'll find such a planet and actually turn it into a bustling intergalactic metropolis someday. But until then, let's enjoy and tidy up our dear Earth.
Is it possible to put out the sun? For example, what would happen if we poured all of the Earth's oceans on it? Or even more water? Well, let's find out. The universe is a place full of mysteries. Since ancient times, scientists have been arguing about how space works. But none of us has ever doubted the existence of one thing: the sun. The center of our solar system. It's big, bright, and immortal? Nah, not really. Actually, the sun is just an ordinary star. It consists of 75% hydrogen, a little helium, and a pinch of other heavy elements. Gravity holds it all together. But in around 5 billion years, the life cycle of the sun will come to an end. The hydrogen inside it will run out. Our star will begin to grow gradually, and you can't even imagine just how big it will become. And then it will start eating all the nearby planets. That's when we'll regret being so close to it. After eating us all, the star will remain a red giant for another billion years or so. And then, sooner or later, it will begin to shrink and fade, turning into a white dwarf. In the end, nothing will remain of it but a bright and colorful planetary nebula. But don't get scared. Right now, the sun is in the middle of its life cycle. It was born about 4.5 billion years ago, and about the same amount of time remains. Fortunately, we were born during the star's best and most stable period. In other words, there's no reason to worry. So let's find one. How about speeding up the sun's life cycle with the help of water? We'll try to collect all the water on Earth and pour it onto the sun. First, we'll need a bucket. No, not this one. We'll need a really, really big bucket. The one that can contain around 326 million cubic miles of water. It will be equal in size to the distance from Washington to Chicago. Or if we can only find ordinary buckets, there should be around 70 quintillion of them. This is a number with 18 zeros. Okay, imagine that we magically got that many buckets. It's time to put out the sun. We splash the star with all this water and nothing? Seriously? Oh, just look at this. The sun has probably felt sorry for us and produced one little solar flare. It turns out that all water on Earth is actually just a pathetic drop for the sun. People often underestimate how much bigger the sun really is than our planet. In reality, it can fit more than 1,003,000 Earths. So yes, the sun won't go out or even get colder. It won't even notice that we've done something. But let's not give up. We really want the sun to go out for some reason. What happens if we pour just enough water on it? And how much is this enough? Remember our quintillions of buckets? Well, we actually need about 370 octillions of them. This number has 27 zeros. It's hard to even imagine, so let's just say that it's a lot of water. Now, let's splash it all over the sun again. Wow, just look at the steam! But the sun hasn't gone out again. On the contrary, it said thank you and suddenly became much bigger and brighter. What's happening? You see, the sun isn't actually a campfire. Inside bonfires, candle flames, there's a chemical combustion. When we pour water on the fire, the water absorbs the heat of the flame and cools it to such an extent that it can no longer maintain the burning reaction. It also blocks the fire's access to oxygen. Water basically stops the chemical process. But the burning of the sun isn't the same reaction. Even though we say it burns, it's not entirely true. What happens there is called nuclear fusion. It's one of the most violent and craziest reactions in the universe. There are many layers of hydrogen going deep into the sun. If you take 4 hydrogen atoms and ram them together, you're left with an atom of helium. When we talk about the sun, the process is a little more complicated. When the star tries to carry out that fusion, positive protons repel each other. It takes a lot of force and energy to somehow squeeze them together. Fortunately, there's a magical force in space. It's gravity. The sun takes up 99.8% of all the mass of the solar system. Pretty heavy, right? And all this mass is what holds the sun together with the help of an incredible gravitational force. So, gravity takes quadrillions of these little hydrogen atoms and pushes them together every second of every day. And when they collide, they release some energy. So, unlike fire, the sun doesn't need oxygen to live. It needs hydrogen. And we all know that water is H2O. It consists of hydrogen and oxygen. So this is literally fuel for the sun. It's like trying to put out a fire with gasoline. More importantly, the extra mass added by water will make the sun heavier. Now, gravity says, "Thank you for your help." And then it starts to collide protons with each other even faster. And thanks to this, the synthesis speeds up. Great, we've made the sun incredibly strong, and now it has eaten us, along with other nearby planets. And if we keep adding water, the sun will sooner or later collapse in on itself. It will blow off its outer layers and become a black hole. Awesome! Now it will pull inside absolutely everything around. Good job, guys. Let's press rewind because clearly our water experiment was a mistake. One small solar flare sounds much better. Alright, we're back to our usual calm sun. But it seems like there's something that we've forgotten. Well, apparently water was critically important for life on Earth. Who would have thought? Now there's a huge amount of unmoving fish and other marine creatures lying around where the oceans used to be. Poor things. As for deep-sea creatures, they simply didn't withstand such a sharp change in pressure. Algae and corals have also dried up. Wait a minute, weren't they responsible for producing 50 to 80% of the world's oxygen? Oops, it's time to put on some oxygen masks. And how are things on dry land? I mean, now everything is just land. But you get the point. Wow, this whole place is lit, and I mean it literally. If there are no oceans, then there are no clouds or rain. Now there are forest fires everywhere. Poor animals have to escape and leave their homes. Oh my. And it's not like they'll be able to find a new home, because all plants, of course, will dry up quickly. There will be literally no place for living left on the planet. So now Earth looks like a giant desert. Great! But people have been living in deserts for thousands of years, right? Maybe they'll know what to do. They won't. After all, people in the desert also need to drink. So now there's total chaos everywhere, and survivors fight for the last drops of water. If there are any survivors at all. In fact, no matter how much they fight for resources, their fate is sealed. The ocean absorbs a huge amount of CO2 and the heat coming from the sun. They also distribute this heat throughout the planet, making it pleasant to live on. But once they're gone, the temperatures will quickly jump to 250 degrees Fahrenheit and above. But even if we forget about the high temperatures, now we have no clouds, and they helped us too, by not letting through solar radiation. So we're also under the direct impact of the sun's rays. Our last hope is icebergs. Now that everything is terribly hot, they've melted. And maybe they'll be the last hope for humanity. But that cool solar flare was definitely worth it. Silly humans.
Hey, ready to test your knowledge? Of course you are. You'll get 1 point for each correct answer. So, without further ado, the sun is yellow. Do you think this is a myth? Ask someone to draw a picture of the sun, and chances are you'll get a yellow or orange circle in the sky. Surprise! The sun is not really yellow. If you see it somewhere outside the Earth's atmosphere, it'll look white. How come? According to NASA, the sun's temperature is the reason why it's white. The sun consists of all colors mixed together, so it appears to our eyes as white. Then why do you think we see it as yellow or orange from Earth? Colored wavelengths, which are yellow and orange, are longer, and they are the only ones that make it to our eyes. The other short wavelength colors sprawl in the atmosphere, and the sky looks blue to us during the day for the same reason. Meteorites are hot as fire when they land on Earth. What do you think, myth or fact? When people see a fireball around a meteorite, they think it's super hot. Well, this is a myth. Meteorites don't immediately land on Earth. Most of them have been in space for billions of years. Space has a cold environment, just a few degrees above absolute zero cold, you know. But don't meteorites fall into the Earth in flames? How come? The fireball is actually the air in front of the meteorite. It is compressed by the super high speed of the meteorite. The outside catches fire, but that layer is burned off on impact as a result of landing on Earth. As you would probably guess, when they land, the meteorites are lukewarm at most, but not as hot as lava. One side of the moon is permanently in the dark. Do you think this is a myth or a fact? This is a myth. Oh, come on. First the sun and now the moon. Am I living a lie? So, people look at the sky and see only the bright side of the moon. The reality is the Earth shines equally on all sides of the moon as it rotates and orbits the Earth. Half of the moon is in shadow, and half gets sunshine similar to Earth. That's not true. Similar to Earth, it doesn't have a permanent dark side. The logic is simple. The moon orbits Earth, but it also rotates on its own axis. When you think about it, we're always looking at the same side of the moon. Black holes take in everything that comes their way. What is it, myth or fact? Black holes don't have infinite mass and gravitational force, but still, no one really knows for sure what happens to the things pulled into them. Experts do know black holes do not have supergravity, though. Let's imagine this. If there was a black hole as big as the Sun, it wouldn't immediately eat the whole planet. Imagine black holes as vacuum cleaners. It does draw in a cloud of dust near its range, but other specks of dust remain where they are. So even if there was a black hole replacing the Sun, all the planets would continue to orbit similarly. They wouldn't go into the black hole. If a star or something else got into the range of the black hole, only then would its gravity affect the star. When you call someone, the signal bounces off a satellite. Is this a myth or a fact? Yep, it's a myth. Or rather, an urban legend or misconception, you name it. I mean, there are some satellite phones, but we, regular people, don't use those every day. Although your mobile phone works in a much different way. When you call someone, the nearest tower connects you to the other person online. This is why there are tower connections, huge networks of tower-to-tower connections, and hidden cables. The moon has no gravity. Any guesses? Myth or fact? This is an urban legend. Ask any astronaut you know. If you don't know any, just trust me. There is footage proving that the moon has gravity. When I say the moon has gravity, don't think it's similar to the gravity on Earth that makes the apple fall. The moon's gravity is only about 1/6 of Earth's. How does it feel to walk on the surface of the moon? The second man on the moon, Buzz Aldrin, mentioned it's like moving in slow motion and, quote, perhaps not too far from a trampoline, but without the springiness and instability, end quote. The sunset on Mars appears blue. Do you think this is a myth or a fact? This is a fact. Magnificent sunsets. The sky is filled with different shades of yellow. Now imagine this in blue. According to NASA, sunsets on Mars would look bluish, watching them with bare eyes. It's because of dust. Dust particles closer to the sun appear in blue tones. There is something called moonquakes. Does it sound like a myth or a fact? It's a fact. Quakes happen on the moon too, and they're called moonquakes. They have different features, not really similar to the quakes on Earth though. A planet can be hot enough to vaporize rocks. Any guesses? Is this a myth or a fact? This is a fact. The temperature in this universe is indeed very high. There's a planet, the temperature of which is enough to melt and even vaporize rocks. It's 2 times bigger than the Earth. This super-Earth is similar to our planet, but it is way too hot. Experts believe that it possibly has oceans of lava and clouds that rain molten rock. 1 million Earths can fit inside the sun. Do you think this is a myth or a fact? This is a fact. Although the sun is one of more than 100 billion stars in the Milky Way, which is at the heart of our solar system, it can fit 1 million Earths. Yeah, it looks small when we see it from here, but it's only because it's so far away from Earth. All comets have tails. Myth or fact? It's true. Some comets simply don't show their tails. They look like someone threw a snowball into space. Space is completely silent. What do you say? Shh, I knew it was too easy. This is a fact. Space doesn't have an atmosphere, so there's no way to hear any sound there. Mercury is the hottest planet. Myth or fact? Mercury is the closest planet to the Sun, so this should be a fact, huh? No, not really. Venus is the hottest planet in our solar system and the second planet from the Sun. But the distance from the Sun isn't what defines the temperature. The heat depends on the atmosphere. So Venus's atmosphere consists mostly of carbon dioxide and some nitrogen. This combination makes the atmosphere very thick. When I say thick, I mean it. Throughout the year, the surface of Venus maintains a temperature of around 860 degrees Fahrenheit. Mercury's surface resembles the temperature of a desert, but is much higher in terms of temperature variations. Venus spins clockwise. What do you say? This is a fact. Venus spins in the opposite direction compared to many other planets. The Sun rises in the west, and its rotation is very slow. Venus needs 225 Earth days to complete its spinning around the Sun. The planet's distance from the Sun affects the duration of one rotation. It's too close to the Sun, and the Sun has a strong, noticeable pull on the planets. Footprints on the Moon can stay there for millions of years. Do you think this is a fact or a myth? Fact checked. The Moon has no atmosphere, so there's no wind blowing, and without the wind, there's no way to erase the footprints without any intervention. So, how many points did you get? Let me know in the comments.
There are 8 planets in our solar system, and they're all very different from one another. That's why, if one day they unexpectedly and inexplicably turned into humans, these people wouldn't look alike, and their characters would differ dramatically. Let's try to imagine what humans the planets of the solar system would make. Do you like our videos? Write about it in the comments, and please subscribe to our channel. Let me introduce Mercury. It's a curious and swift teenager around 13. 15 years old. He's always on the move and is a bit hard to pin down. He's into sports and tends not to walk but dash around. That's one of the reasons his knees and elbows are always scratched. He's just like the planet Mercury with all its countless craters. Now, meet Venus. It's a beautiful young lady in her mid-20s. She likes to keep her secrets, and her alluring beauty comes with a temperamental side. At parties, she easily attracts attention because of the mystery surrounding her. But those who dare strike up a conversation with this beauty soon realize that she's scorchingly direct and doesn't tolerate nonsense. Earth is in her late 20s. She is very pretty and extroverted, and has a nurturing, balanced personality, forever the peacemaker, trying to maintain harmony. Earth is the one everyone turns to for advice and comfort. She has a pretty unusual hobby, collecting different life forms, like someone who always brings home stray animals. And if she feels that something or someone is a threat to her beloved pets, she can get furious. Mars is a cool guy in his early 20s. He's ginger and sturdy. He's that ambitious and a bit annoying younger brother, living in Earth's shadow. But he doesn't give up and is determined to make a name for himself. He's a great fan of adventure and exploration, that very type who enjoys camping, wilderness, and slightly dangerous activities. His guilty pleasure is Googling stories about ancient warriors. Jupiter is in his early 50s. He is that protective elder with a bigger-than-life personality. He is a respected head of a large family, known for his wisdom and jovial nature. He also loves to throw big parties that sometimes get out of hand. Saturn, an elegant lady in her late 40s, is stylish and timeless. She is always the best-dressed person at any gathering. She's known for her beauty and has a calm, sophisticated demeanor. She loves accessories, especially elaborate rings. She's got quite a collection. Uranus is in his late 30s, and he has an unconventional, quirky personality. If you have a problem and need a different perspective on something, he's the one to go to. No wonder his planet counterpart has a unique axial tilt. Uranus isn't afraid to be different. He enjoys innovative and boundaries-pushing art, and some suspect he might be a hacker. Neptune is a thoughtful man in his early 40s. He's kind of a dreamer and probably the most creative one in the group. You can often find him lost in thought or swept away by music. He's almost always wearing his large blue headphones. He's very sensitive and has a high emotional intelligence. This quality draws others in. That's not all. Let's look at a space body that used to be a planet, Pluto. It's a very young teenager, quiet and often overlooked. But he has a surprising amount of depth. Despite his introverted nature, he has a group of close-knit friends. It might take time to get to know him, but those who gain his trust discover his different side, endearing and witty. The sun is a big boss. No one knows how old he is because he looks ageless. Rumor has it he frequents beauty clinics, but shh! The sun knows his worth and uniqueness. He's quite caring and nice to his subordinates, but he's also rather hot-tempered, and when he gets angry, he expresses his displeasure openly, often by throwing stuff. The moon is a shy 18-year-old girl. It's hard for her to make new friends. She prefers to keep close to the only friend she has, which is Earth. To her, Earth is a motherly figure who can protect and give valuable advice. The moon has some skin problems, which also makes her feel rather insecure. But don't worry, Earth is working on her confidence. The universe is expanding, and if it's expanding, then it probably had a beginning somewhere. Now, all we have to do is to run time backward and see where the beginning was. It took the scientists many more years to come up with a full-fledged theory. The Big Bang Theory. And here it is. Nothing has ever been anywhere, because neither when nor where existed. But actually, no. There was one thing. It was the so-called cosmic singularity, a state of our universe in which it was incredibly small, dense, and very, very hot. Imagine if our universe was compressed into a small ball. The pressure and temperature inside would be enormous. At some point, it became impossible to withstand them. And here comes the Big Bang. It was an outburst of energy and matter that created everything we see now. Time and space, basic physical forces. It also scattered quarks everywhere. These quarks, tiny particles that make up our world, were all boiling in an incredibly hot cosmic broth. When it cooled down, gravity began to attract them to each other. They gathered into atoms, then molecules, and then into the first objects in the world. Stars. But what was before that? Alan Harvey Guth, an American theoretical physicist and cosmologist, has devoted his whole life to solving this mystery. After learning about the Big Bang Theory, Guth found some flaws in it. For example, the distribution of matter was very even, although it shouldn't have been. If we drop the balloon filled with paint down, it will burst, and we'll see absolute chaos on the canvas. But the early universe don't look like. The early universe was very even and proportional. That was Guth's discovery, the theory of inflation. Here's what it says. Even before the Big Bang, there was some kind of force that could give the bang a strong acceleration, something that was able to distribute everything in space instantly and evenly. Martin Boyovald is a German professor of physics, and in his opinion, the universe was born quite differently. According to Martin's theory, the singularity couldn't just appear out of nowhere. Let's look at a pendulum on the old clock. The pendulum rotates back and forth. Its movement is smooth, continuous, and non-stop. This is how we usually see time. It flows and never stops. But quantum time doesn't work that way. It consists of small segments and makes short pauses. And just like with the second hand of a clock, the beginning of one segment of time is always the end of another. According to the Big Bang Theory, once upon a time, our universe began to expand, inflate like a balloon. But sooner or later, it will blow away back. The universe will start shrinking and return to the state of cosmic singularity. And then, the Big Bang too. Nothing appears out of nowhere and disappears into nowhere. According to Boyovald's theory, the beginning of each universe is the end of the previous one. Our universe is not at all the first and not the last. Millions of similar universes existed before us and will exist after us. This theory, although it sounds very logical, is far from complete. So for now, all this is just a hypothesis. But some people come up with even stranger ideas. Neil Turok, a South African physicist, and his colleague Paul Steinhardt, an American theoretical physicist. They say that yes, our universe isn't the first one. Our universe is just one of an infinite number of others, and all of us are stuck in a cycle of endless rebirths of parallel worlds. According to this theory, our universe is located inside a so-called brain, as in membrane. In other words, we're stuck in some kind of elastic surface that's capable of contracting, stretching, oscillating, and so on, like pieces of fabric on a rope. Another universe may be an inch from ours, but we can't see it. That's because there's a tiny space between us, and this tiny space contains the fourth dimension. How do these universes originate? Through brain collision. These brains are getting closer to each other very, very slowly, until they finally collide. Their collision creates two big bangs and two parallel universes. Then they're moving away from each other. The created worlds continue to live. We're currently at this stage. Remember the inflation theory? There was a mysterious energy that pushed and accelerated the Big Bang. Well, if we did collide with another universe, that would explain everything. Which idea is closer to you? How about the idea of subscribing? Subscribe. The main question of all time goes like this. What was there before the Big Bang? The most common theory claims that about 13.7 billion years ago, before this incredible rapid expansion occurred, the universe existed as a singularity. It was a point tinier than a subatomic particle. At least, that's what the Big Bang theory tells us. Okay, but what was before that? This question has been bothering the minds of the greatest cosmologists for at least 1,600 years. For example, 4th century theologian St. Augustine was trying to figure out the answer to the question of what had existed before the universe was created. He made a conclusion that the phrase, "in the beginning," mentioned in the Bible, implied that nothing had existed before that. He also believed that time and the universe had been created simultaneously. The ancient Greeks were also bothered by the same question and kept debating the origin of time. Philosopher and scientist Aristotle, for instance, took the no-beginning side. He thought that nothing could come out of nothing. In other words, to get a universe, you need to have something for this universe to appear from. And since the universe couldn't have gone from nothingness to somethingness, it must have existed forever. That's why time must stretch eternally into the past and future. In the early 20th century, the world got to know about Albert Einstein's theory of general relativity. According to this theory, mass warps time, making it run a bit more slowly for, let's say, a human standing on Earth's surface and a satellite orbiting our planet. Based on Einstein's work, other ideas started to pop up, including the one that stated that the universe started as a singularity and expanded through the Big Bang. Then, quantum physics came into play. It gave birth to a bunch of new theories, which brought forth the questions about the pre-Big Bang universe again. And aren't these ideas fascinating? Some researchers believe that our universe is just an offspring of another much older universe. According to them, the evidence for this theory can be found in the cosmic microwave background, CMB, which is the relic radiation left over from the Big Bang. But let me explain. For the first time, astronomers observed the cosmic microwave background in 1965. At that time, they didn't know it would soon create problems for the Big Bang theory, challenging its ideas and postulates. Now, according to the inflation theory, an extremely rapid expansion of the universe occurred in the very first moments of its existence. This theory accounts for the changes in temperature and density in the CMB. It also claims that these fluctuations should be uniform. But recent mapping results show that the universe is actually lopsided. More fluctuations occur in some areas than in others. This makes some scientists believe that our universe bubbled off a parent universe. There's also a chaotic inflation theory, which takes this concept even further. It believes in an endless progression of bubbles, each eventually becoming a universe. And each of these appearing universes gives birth to even more bubbles, which results in an immeasurable multiverse. There are other models too. Some of them revolve around the pre-Big Bang singularity and black holes. If we think of these space monsters as cosmic trash compactors, they might end up being the main candidates for primordial compression. And our rapidly expanding universe could be a white hole output from a black hole dwelling in another universe. A white hole is a hypothetical object that acts in the opposite way to a black hole. Instead of pulling everything inside, it constantly gives off energy and matter. There's also the Big Bounce theory. Its main idea is that instead of going through one Big Bang, the universe expands and contracts in a cycle, bouncing back every time it shrinks to a certain size. Each cycle, therefore, begins with a tiny, smooth universe that gradually grows, becoming more warped with time. And eventually, it starts to collapse, smoothing itself out before starting anew. If you liked or disliked our video, put a like or dislikes. Leave comments. Let's discuss the mysteries of the universe together. And now don't leave, the video will continue. Have you heard of quantum immortality? These days, many people are confused about this notion. But if you believe in it, you also believe that you can live forever. How come? Well, quantum immortality claims that nobody ever disappears forever, and that consciousness never passes away. Instead, once you cease to exist in one universe, your consciousness simply gets transferred to a parallel universe, and there, you survive. This idea sounds more like a sci-fi movie than something that real science can suggest. It could be a script for a blockbuster. People's consciousness can transfer from one world, where an apocalyptic event has wiped out all life, to another, where such an event has never occurred. And the only clues about the slight differences between these worlds are a few Mandela effects. This phenomenon is named after people disremembering Nelson Mandela's passing. These days, the term is used to refer to any collective false memories. So maybe in that new world, millions of people will be wondering, since when has Pizza Hut been written with 2 T's? But the thing is, in this new reality, this popular brand name has always had 2 of them. Imagine going through apocalypse after apocalypse, transferring to one world after another. It might be a nice, if a bit horrifying, thought that you're going to live forever. Instead of passing away completely, you'll just keep transferring to a universe where nothing tragic has happened to you. But is there anything to this theory? What does science think about such a possibility? In fact, the idea of quantum immortality has been around for quite some time. It has been seen both as untestable nonsense and as a curious thought experiment, like the one involving a cat. And here, I mean Schrödinger's cat. Let me explain. According to one of the interpretations of quantum mechanics, particles can exist in several states at the same time. But when a particle is being observed or measured, this system collapses. As a result, the particle is found in just one of its possible states. In 1933, Schrödinger suggested doing a certain thought experiment. He believed it would show the absurdity of this idea. In his hypothetical scenario, a cat was placed inside a box with radioactive materials. These substances had a 50-50 chance of decaying over an hour. If it happened, the radioactivity would be detected by a Geiger counter, which, in this case, would smash a vial with poison. As you might assume, it wouldn't end well for the cat. Schrödinger saw the following problem. The cat in the box would be both alive and not alive at the same time. The animal would be in this state for an hour, until someone opened the box and checked on the feline, either lifeless or very annoyed. One solution to this problem, known as the many worlds interpretation, gets around this situation by claiming that both outcomes take place. According to this hypothesis, all possible outcomes of quantum measurements occur across many universes, and their number might be infinite. It probably doesn't come as a surprise that this theory is often criticized. Many mention that this idea is unfalsifiable, since universes don't interact with one another, making the theory impossible to test. It's even been called one of the most implausible and unrealistic ideas ever. After all, it's not clear why your consciousness would get transferred between worlds just because you cease to exist in one of them. Unless it's a thought experiment, of course. It might provide you with the comfort of knowing that there is another you who doesn't pass away in a different world. But why should you believe that you only exist in the world where you're alive? What about the universe where you didn't make it? Like, what happens to your body? And speaking of the suggestion that you might understand that you're in a different universe thanks to Mandela effects, it's kind of the area of science fiction. Throughout the years, scientists have made some discoveries that seem to hint at the existence of extraterrestrial life. But do they really? Let's find out. In 1976, NASA's Viking Mars landers detected chemical signatures that could be a sign of extraterrestrial life. During one of the experiments, Martian soil was mixed with special nutrients and then tested for the production of methane gas, and the test's result was positive. In other words, something in the soil was metabolizing these nutrients and producing the gas. Unfortunately, other experiments conducted on board the landers didn't show any evidence of life. It caused NASA to declare the result a false positive. And still, some scientists keep standing by the finding, arguing that the experiments on board were ill-equipped to look for a key indicator of life, organic molecules. In 1977, an Ohio State University radio telescope detected a bizarre pulse of radiation coming from someplace near the Sagittarius constellation. It lasted 37 seconds and was so unexpected that the astronomer who was monitoring the data at that moment scribbled, "Wow," on the telescope's printout. The thing is that the radio frequency of the signal is internationally banned on Earth. The signal could be the result of a supermassive astronomical event, or it could be sent by some kind of intelligent life with immensely powerful transmitters. So far, this mystery has remained unexplained. In 1996, NASA scientists announced that they had found something that could be microbes in a potato-shaped chunk of Martian rock. The meteorite might have been blasted off the surface of Mars in a collision. It had been wandering the solar system for about 15 million years before it fell in Antarctica. Analyses showed that the meteorite contained some organic molecules and tiny particles of the mineral called magnetite. It's sometimes found in bacteria living on our planet. NASA researchers used an electron microscope and announced that they had spotted nanobacteria. But since that time, this evidence has been called into question a few times. Some experts say that the particles of magnitude are not really similar to those found on our planet, and Earth's contaminants are likely to be the source of organic molecules. Jupiter's moon Europa has a bizarre red tinge. Some of the theories explaining this phenomenon have suggested the reason is frozen bits of bacteria, which are also responsible for the mysterious infrared signal the moon gives off. But this theory hasn't been proven yet. The existence of life in Venus's clouds might explain curious anomalies in the composition of the planet's atmosphere. Solar radiation and lightning are supposed to generate tons of carbon monoxide on Venus, but in reality, this gas is rare, as if something is removing it. Another weird thing is the presence of both hydrogen sulfide and sulfur dioxide in the atmosphere. Usually, these two readily react together. That's why it's rare to find them coexisting. The only explanation can be that some process keeps churning them out. But probably the most mysterious is the presence of carbonyl sulfide. The thing is, on Earth, it's only produced by microbes and not by some inorganic process. Some experts believe that microbes might be living in the atmosphere of Venus. The surface of the planet, scorching hot and acidic, isn't very suitable for the development of life, but up in the atmosphere it's moist and hospitable, with a pressure similar to Earth and pleasant temperatures. But again, we haven't received any solid proof yet. In 2003, scientists discussed the possibility that the traces of sulfur on Jupiter's moon Europa could be the waste products of colonies of underground bacteria. The compounds were first discovered by the Galileo space probe, which also found some evidence of a volcanically warmed ocean beneath the icy crust of the moon. The sulfur signatures look similar to the waste products of bacteria living in the surface ice covering lakes in Antarctica on Earth. But other scientists rejected the idea. They argued that the sulfur could have come from the neighboring moon. Io there, it's found in abundance. Our channel has new space-themed videos every day. Let's check how closely you watch them. All the answers to these questions have already been voiced in our videos. Let's go. Level 1. Asteroids are small planets. False. Asteroids are small celestial bodies that are not planets. Saturn is the only planet in the solar system that has rings. False. Saturn has rings, but other planets in the solar system also have rings, such as Jupiter, Uranus, and Neptune. The closest planet to the Sun, Mercury, is the hottest planet in the solar system. False. The hottest planet in the solar system is Venus. Its temperature reaches 462 degrees Celsius. The Sun is yellow. False. It is actually white in color. It appears yellow from Earth because of light scattering. All stars emit light. True. All stars emit light. Too easy. Level 2. All comets have tails. False. Only comets that come close enough to the Sun have tails. Comet tails are made up of dust and gas that are heated and vaporized by sunlight. Space is always cold. False. In space, temperatures can vary widely, from very low temperatures in interstellar space to very high temperatures in the neighborhoods of stars. There is a magnetic field in space. Truth. There's a magnetic field in space. There are black holes in space that spin faster than light. False. As we know, nothing can move faster than light. Gravity is the only force that acts in space. False. There are other forces at work in space, such as the electromagnetic force and nuclear forces. Level 3. There are stars that are colder than the human body. True. Brown dwarfs belonging to spectral class Y are the coldest known star-like objects. Some of them can have temperatures around 25 degrees Celsius. If Saturn were placed in water, it would float on the surface. True. Saturn's density is lower than that of water. The phases of the moon are created by the Earth's shadow. False. The phases of the moon are caused by the motion of the moon around the Earth, relative to the sun. When the moon orbits the Earth, to an Earth observer, some parts of its surface are illuminated and others are in shadow. More than 100,000 meteorites fall to Earth every day. False. According to the American Meteor Society, between 10 and 50 meteorites fall to Earth every day. All planets in the solar system have natural satellites. False. Mercury and Venus are the only planets in the solar system that do not have satellites. How many questions did you answer correctly? Write about it in the comments. And until the next videos,